today. That is the lecture that started off free fall motion. And the questions that I asked you to look at were not even really homework questions, but they were just examples from the end of that section of the notes. So we're going to do example 1 and 2. Actually, they both say example 1. I should say example 1 and 2, but they're essentially the same thing, but with different values. So this is example 1 out of the notes, and we're going to be looking at finding the final velocity and final height of an object as it was thrown up in the air. So let's write down our givens right now. So we have an object with a velocity that is thrown upwards with a velocity of 40 meters per second. So the initial velocity is 40 meters per second, and that's positive because if it's thrown upwards, we consider that to be positive. The elapsed time, or the change in time, is 2 seconds. We have what else do we know? Oh, we know the acceleration, right? What's the acceleration? The acceleration is what we call g. I'll just put g there. But what is g? G is negative 9.81 meters per second squared. So the question is what? What's the velocity? What's the final velocity at that time right there? So VF is what we do not yet know. Well, let's find it. We do have an equation, in fact, just for that. That's our final velocity is initial velocity plus acceleration times time. And when we put in our g for acceleration, that changes that plus sign up front to be a negative. So it would really wind up being final velocity equals initial velocity minus gt. That is minus that negative acceleration times t. In fact, I probably shouldn't say it like that. You're not minusing a negative. You're subtracting the magnitude, which is 9.81. But we write it as negative 9.81. So don't double up your minuses. So don't subtract a minus and wind up getting a plus. Just make sure your minus sign is out front, and you'll do fine. So let's punch in our numbers here and solve for final velocity. What's our initial velocity? Oops, that's 40 meters per second. And then we're subtracting 9.81 meters per second squared times the time, which is 2 seconds, right? 2s. So that means that our final velocity, if we punch all that into our calculator, that's going to be 20.4 meters per second. So that means that it was thrown upwards with this velocity right here, but since gravity is tugging on it in the opposite direction, constantly tugging on it, it's going to slow it down. So after 2 seconds, it will slow down to 20.4 meters per second. Now the question is, what's the height? What's the height after 2 seconds? Well, again, let's write down our knowns. Our initial velocity is 40 meters per second. Our final velocity, we know by now, but we shouldn't necessarily need it, but we'll just write it down anyway. Our final velocity is 20.4 meters per second. Our acceleration is still negative 9.81 meters per second squared. And that should be an A right there. That's a pretty horrible A. And and our time, our elapsed time, that's going to be 2 seconds. Well, we have an equation that solves this wherein we really don't even need our final velocity right here. All we need to know is our initial velocity, our acceleration, and our time. And that is where we solve for the displacement y. That is displacement y, or the change in y, change in our position or location on the y-axis, is going to be initial velocity times time plus 1/2 times acceleration times time squared. But once again, we're going to plug in our values for initial velocity and time and acceleration, and that'll help us to solve for our y displacement. So our initial velocity is 40 meters per second times time, which is 2 seconds. Now, instead of adding 1/2 at squared, remember, since the a is negative, that's going to make that whole value negative. So we're going to subtract 1/2 times, what's the value of our acceleration? 9.81 meters per second squared times time squared, which is 2 seconds squared. Okay, remember, if we had kept this a plus out here, we would have had to put the minus in here, negative 9.81, but we simply put the minus out front. So again, don't double up your minuses. The negative 9.81 makes the second half of the equation a minus, so that whole second part is going to be subtracted from the first part. Well, what do we get when we punch this into our calculators? That should give us 60.4 meters. I realize you're probably thinking this is a voiceover, which it is, and bad picture-in-picture editing, but it's also the right answer. So 60.4 meters. There you go. So that's example 1. Now let's look at example 2. And again, it should say example 2 right here. Example 2. Essentially, they're the same thing, but let's just go through it again just for practice's sake. And the answers are actually going to be discussion worthy as well. So, number 2, our initial velocity. That's 40 meters per second. Our time is going to be 7 seconds. Our acceleration equals 9.81 meters per second squared. And we want to know the final velocity. Final velocity is going to be equal to initial velocity plus acceleration times time. So that's going to be 40 meters per second minus, remember, 9.81 meters per second squared times our time t, which is 7 seconds. That gives us a value, or a final velocity after 7 seconds of negative 28.7 seconds. Negative 28.7 seconds. Or I'm sorry, seconds. I'm going crazy here. Meters per second, right? Meters per second. Let's see if I can just erase that. There we go. Meters per second. Now take a look at this. You're initially going upwards at 40 meters per second, but given enough time, eventually your object's going to be moving downwards. So what's happened to it in between there? Well, it reached an upwards turning point, and so it reached the point where it's not moving at all, and then it starts coming downwards negatively right here. And so after 7 seconds, it's actually started to move back down because of gravity. What's the final height after 7 seconds? Again, the setup is the same as last time. But let's just punch it through. I have all my givens up here, so I'm not going to write them down again for the sake of time. But our equation that we're going to use for height, or the change in height, is initial velocity times time plus 1/2 times acceleration times time squared. So our change in y, or our change in displacement in the y-axis, is going to be 40 meters per second times 7 seconds squared, which is 7 seconds squared. So that gives us a total displacement in the y direction after 7 seconds of right around 40 meters. So there you have it. That's our example 1 and 2 from the notes. I asked you guys to look at these in class, and hopefully you tried them on your own before checking out these videos here, but we're going to be moving on tomorrow, so hopefully you have these well under your belt so that we can move on to the next thing. If you have any questions, please ask me, but I'll talk to you tomorrow. See you then.